Hey there, welcome to an About 6 Minutes channel. So you've probably heard the term quantum computer and thought, sounds cool, but what the heck is it? Well, today we're going to break it down, super simple. No physics degree needed, I promise. Let's start with the computers we use every day, like the one you're watching this on. These are called classical computers, and they work by using bits, tiny on-off switches that represent either a 1 or a 0. With enough of these bits, you can do everything from watching videos to sending emails or running video games. But classical computers have limits. Some problems, like simulating molecules, breaking encryption, or optimizing huge systems, are so complex that even the fastest supercomputers today would take thousands of years to solve them. That's where quantum computers come in. Instead of bits, quantum computers use qubits. And here's where things get weird, in a good way. A qubit can be a 0, a 1, or both at the same time. This is called superposition. Think of it like spinning a coin. While it's spinning, it's kind of both heads and tails, right? That's a bit like what a qubit is doing. And then there's entanglement. This one's wild. Two qubits can be connected in such a way that whatever happens to one instantly affects the other, even if they're far apart. Einstein called it spooky action at a distance. Because of superposition and entanglement, quantum computers can process a massive number of possibilities all at once. It's like trying every key in a lock simultaneously instead of one at a time. So, how does this help us? Well, for starters, medicine quantum computers could simulate molecules to help design better drugs, faster and cheaper. Climate modeling? They could crunch numbers that help predict weather and climate changes more accurately. Cybersecurity? They might crack encryption, yes, that's scary. But they'll also help build better encryption. Logistics and finance. From planning delivery routes to forecasting the stock market, they could optimize systems way beyond what we can do now. Sounds like magic, right? But here's the catch. Quantum computers are still in their early stages. They're super sensitive. A tiny vibration or temperature change can mess things up. That's why most quantum machines today are huge, complicated, and need to be kept near absolute zero. We're not yet at the point where you can buy a quantum laptop at Best Buy, but big companies like Google, IBM, and startups all over the world are racing to make them better and more stable. So, to sum it up, classical computers use bits 0 or 1. Quantum computers use qubits 0 and 1 at the same time. That lets them explore massive problems faster than ever. We're still in early days, but the potential? Game-changing. Quantum computers won't replace your phone or your laptop, but they'll work alongside classical computers to do the things we can't do today, especially for science, medicine, and complex problem-solving. Hope this made quantum computing a little less intimidating, and maybe even a little exciting. If you're curious to learn more, drop a comment or a question below. Thanks for watching, and welcome to the quantum future.